Law of conservation of energy. The law of conservation of energy is total energy in the universe remains constant. Energy can neither be created nor be destroyed. Energy can transform from one form to another form. This is basic statement of law of conservation of energy. Now, to learn more about law of conservation of energy, here we need to know about two kinds of forces. What are the two kinds of forces? The first one is conservative force. What is meant by conservative force? Conservative force is a force with a property that the total work done in moving a particle between 2 points is independent of the path taken. That is conservative force. Hence, if a particle travel in a closed loop means what happens? Initial position, final position both are same. So, if a particle travel in a closed loop, the total work done by a conservative force is 0. Total work done means the sum of the forces acting along the path is multiplied by the displacement. Then we get the total work. The total work done in a closed path by the conservative force is 0. Conservative force depends only on the positions of the body. Now, the statement of the conservative force. Here, given that work done by the force around a closed path is 0 and it is independent of the path. Such a force is called conservative force. And one more important relation is there here for conservative force relates with potential energy. How conservative force relates with potential energy means, if force F is defined as F equal to minus du by dx, U is the potential energy, then what we call du by dx? Du by dx is potential energy gradient. By distance terms are there, those we called as gradient. Now, du by dx, potential energy gradient. For example, pressure difference by distance is there, pressure gradient. Potential difference by distance is there, potential gradient, like that. Here, du by dx, potential energy gradient. Negative sign is there. That means conservative force is numerically equal to negative potential energy gradient. Negative potential energy gradient is the conservative force. Then this F is said to be conservative. Then that force is called conservative force. Examples: the gravitational force, elastic forces, electrostatic forces, magnetic forces, etc. All the central forces are conservative in nature. Here, all these forces are central forces. So, these are the examples of gravitational force. Let us assume we want to lift a body of mass m to a height h. What is the work done by the gravity? Minus mgh. Let us assume from ground to certain height h to lift an object, work done by the gravitational force is minus mgh. Again, from that position to you want to bring the body back to the ground. What is work done by the gravity now? Plus mgh. Starts from ground, again come back to ground. Here two works are there. In the vertical upward motion, minus mgh is the work done by the gravity, considered as W1. Now, to bring it back to ground, work done is W2, that is mgh. Now, in a closed path, what is meant by closed path? Starts from ground, again come back to ground. What is the net work done? Is W1, work done to lift to certain height, W1, plus work done to bring it back to ground, W2. W1 plus W2 is the total work done by the gravitational force in a closed path. Means minus mgh plus mgh is equal to 0. Hence, the total work done by the gravitational force to move a object in a closed path becomes 0. Hence, gravitational force is conservative in nature. Next kind of force is non-conservative force. I hope you understand about non-conservative force also. Exactly opposite to that conservative force. There, path independent, here path dependent. There, in a closed path, work done by that force is 0, that force we called as conservative. Here, work done to move a body in a closed path not equal to 0. That we called non-conservative force. If work done by a force around a closed path is not equal to 0 and it depends on the path, such a force is called non-conservative force. Resistive forces usually are the non-conservative forces like air drag, viscous forces, frictional force. These are the examples of non-conservative forces. Friction, viscous force, air drag, etc. are the examples of non-conservative force. So here, frictional force like this. The frictional force is act opposite to the applied force. Now, to move this block in a complete closed path, work done is not equal to 0 by the frictional force. Hence, frictional force is non-conservative in nature. This is the information about conservative and non-conservative forces. Now, law of conservation of mechanical energy. What is mechanical energy? Sum of the potential energy and kinetic energy is the mechanical energy. What law of conservation of mechanical energy states? The total mechanical energy of a system is constant if the internal forces doing work on it are conservative and the external forces do no work. This is the statement of law of conservation of energy. Total mechanical energy of a system is constant if the internal forces doing work on it are the conservative and the external forces do no work. Here, when a body undergoes a displacement delta x under the action of a conservative force F, the change in kinetic energy of the body is given by work energy theorem. So how? Work done equal to change in kinetic energy. F conservative force causes a displacement delta x. What is the work done? F delta x, which gives change in kinetic energy delta Ke. That means delta Ke is the change in kinetic energy is equal to F is a function of x into delta x. Here onwards we get kinetic energy delta Ke. What is delta K? Delta K is the change in kinetic energy. What is the change in kinetic energy? F of x delta x. This one is change in kinetic energy. Similarly, which force it is? It is the conservative force. Here work energy theorem is applicable for all kinds of forces. So here mentioned that this force is conservative force. Now, for conservative force already we know the relation between F and U. F equal to minus delta U by delta X. Negative potential energy gradient is the conservative force. We use that equation again now. If the force is conservative, the change in potential energy delta U is equal to F of X delta X. Negative sign. Minus delta U is equal to F of X delta X. Now, from both the equations, delta K, change in kinetic energy, is equal to minus delta U. Bring this minus delta U to this side. That means delta K plus delta U is equal to 0. Now delta gets common. Delta into K plus U equal to 0. What is K plus U? Kinetic energy plus potential energy gives sum of these two is the mechanical total energy. Total mechanical energy. So, change in total mechanical energy is 0. That is, delta E is equal to 0. Delta E is 0. That means the change in energy is 0. Meaning of this is energy remains constant. Hence, E is constant. Hence, the mechanical energy E is constant. That is the conservation of energy, mechanical energy. The conservation of mechanical energy is total mechanical energy remains constant if conservative force is doing work. Here conservative force only we considered. Okay, na? This one. That is, if the kinetic energy of the body increases, total energy remains constant means kinetic energy plus potential energy is constant. Implies if kinetic energy increases, potential energy decreases by equal amount. If potential energy increases, kinetic energy decreases. Why? Because to maintain constant total mechanical energy. This is law of conservation of mechanical energy. Now, we are going to verify this law of conservation of mechanical energy in case of freely falling body. Now, what is mechanical energy here? According to law of conservation of mechanical energy, total energy remains constant. Total mechanical energy meaning is what? Kinetic energy plus potential energy. That sum is constant, right? Now, a ball of mass m is dropped from a building at a height h. From h height onwards, a ball is dropped. Now, here we consider 3 points in its path. The total mechanical energy of the ball is considered as capital E. What this capital E involves? It involves potential energy and kinetic energy. E equal to kinetic energy plus potential energy. Consider 3 points A, B and C at heights h, means starting point at the top. That point is A. One more is at a height h minus x from the ground, means in its journey somewhere. The last point C is on the ground. Like 3 points we consider. Now, at these 3 points, we calculate total energy. If total energy at these 3 points is same, then we said conservation of energy is verified in case of freely falling body. Means for freely falling body, it obeys law of conservation of energy. Okay. So to do that, here at point A, first point is A, where it's situated at the highest point. Here onwards, you are going to throw this object downward. Okay, now. So this point is A. At this point A, it is the starting point for a freely falling body. Freely falling body means initial velocity is 0. So initial velocity u0 means the kinetic energy of the body, here the ball is the body, kinetic energy of the ball at point A is 0. Here, the kinetic energy of the ball at point A is 0. Why? Because initial velocity for this ball is 0. It is a freely falling body. Now, here we are going to find the potential energy of the ball when it is at A point. At A point, it is at a height h above the ground. It is at a height h above the ground means what is potential energy formula? mgh. So h is h, then the potential energy of the body at A point is mgh. Kinetic energy at A point is 0. Potential energy is mgh. What is total energy? Total energy is potential energy plus kinetic energy. Potential energy mgh, kinetic energy 0. So total energy at A point is mgh. Remember this one. So total energy at A point is mgh. Consider it as equation number 1. Total energy at A point. When the body is at point B, again we are going to find potential energy, kinetic energy, total energy at B point. For B point, the ball reaches to B point. The velocity of the B point is Vb. The distance travelled by the body is x. Then, when it is at B point, to calculate velocity, the velocity at point B is, velocity at A is 0, initial velocity is 0. At B point, ball velocity is assuming as Vb. It is a freely falling body means under gravity it is moving. Means uniform accelerated motion. How much distance it travels to move from A to B? X distance it travels. Hence, the velocity at B point is found by using V square minus U square equal to 2AS equation. What is V? Vb square. What is U? Initial velocity 0 is equal to 2A. How much distance it traveled to reach B point? X distance. That means Vb square is equal to 2gx. U is 0. Means Vb square equal to 2gx. Now kinetic energy at B point. The kinetic energy at the B point is half m velocity at B point square, that is Vb square. In this Vb square, I will write this 2gx. Then the kinetic energy is half m into 2gx. 2 cancel, we get kinetic energy as mgx. This is kinetic energy at B point. What is potential energy at B point? From ground, what is the height of the ball when it is at B? That is h minus x. Now the potential energy usual formula is what? mgh. But h is what here? Height of the ball when it is at B from the ground. What is that height? h minus x. Hence, potential energy P equal to mg into instead of h minus x, which is mgh minus mgx. What is kinetic energy at B point? mgx. What is potential energy at B point? mgh minus mgx. Then the total energy at B point is kinetic energy mgx plus potential energy mgh minus mgx. mgx cancel. Total energy at B point is mgh. That is taken as equation number 2. What is this? Total energy at B point, that is mgh. Total energy at A point also mgh, equation 1. Now, it travels the remaining distance and reaches to ground, to C point. When the body touches the ground at C point with velocity Vc, what is velocity of the ball at C point? That is Vc. Now, Vc again calculated by using uniform accelerated motion equation, which relates initial velocity u equal to 0, velocity at C point VC, and distance traveled to reach C point from A is h. That equation is again v square minus u square equal to 2as. By using that, the velocity at C point we are going to calculate. V square minus u square equal to 2s. V square, Vc square minus 0, u is 0, is equal to g. What is the height of A from C? That is h. This one. Vc square equal to 2gh. This is velocity at C point. Now, kinetic energy at C point is half mvc square. What is vc square? 2gh. Instead of this vc square, I am writing 2gh. 2 cancel. Kinetic energy at C point is mgh. Now, potential energy at C point. Formula is mgh. What is this h? Height of the object from the ground. Now, the object is on the ground itself. Hence, height of the object is 0 here. Why? Because the body situates on the ground when it is at C point. Touches the ground at C. Means height is 0. Height is 0 means potential energy is 0. Potential energy 0, kinetic energy mgh. The total energy at C point is potential energy plus kinetic energy, that is 0 plus mgh. Means total energy at C point is mgh, considered as third equation. Now observe equation 1. What is equation 1? Total energy at A, that is mgh. Equation 2, total energy at B, that is also mgh. Equation 3, total energy at C, that is also mgh. That means from equation 1, 2 and 3, at any point on the path of a freely falling body, the total energy is constant. Hence, conservation of mechanical energy is verified in case of freely falling body. And one more point, here the total energy is in the form of potential energy. In any of these three equations you observe, energy may transfer from one form to another form. At the highest point A, the energy purely in the form of potential energy, that is mgh. Whereas at B, the total energy partially kinetic energy, partially potential energy. At C, the total energy only is in the form of kinetic energy, potential energy is 0. Means energy can transfer from one form to another form, but total energy remains constant. And in case of freely falling body, the total energy is in the form of potential energy, mgh. Thus, the law of conservation of energy is verified. This is law of conservation of energy verification in case of freely falling body. Similarly, in case of vertically projected body also, law of conservation of energy holds good. Let's do some problem based on law of conservation of energy. The problem here is, a boy is swinging on a swing such that his lowest and highest positions are at a height of 2 meters and 4.5 meters respectively. His velocity at the lowest position is, what is the highest position of the person when the swing is at the highest point, that is 4.5 meter. He mentioned it as highest position. Highest position means at that point velocity is 0. That means corresponding to this position, highest point, the velocity is 0. Now the question is what? His velocity at the lowest position. Lowest position is what? 2 meter. For this 2 meter, corresponding velocity we are going to find for this swing. So, to calculate that, here the options are what? First option, 2.5 meter per second, 7 meter per second, 14 meter per second, and 20 meter per second. Solution. Here, total energy at lowest point equal to total energy at the highest point. This is the conservation of energy principle. So that means total energy at A lowest point means potential energy mgh plus kinetic energy half mv square. Highest point total energy means potential energy mgh, height is there, but kinetic energy at the highest point is 0. Hence, the kinetic energy at the lowest point is difference of potential energy at the highest point and lowest point. This we bring from conservation of energy only. So this formula we are going to use to find the solution for this problem. That is, kinetic energy at the lowest point is mgh1, highest point potential energy, minus mgh2, lowest point potential energy. Cancelled. V square by 2 equal to G into H1 minus H2. V square by 2 equal to, what is G? Acceleration due to gravity. Here not mentioned anything. Means G we have to use 9.8 meter per second square. Here 9.8 into H1, highest point height from the ground, that is 4.5, minus H2, lowest point height 2. In simplification, we get V as 7 meter per second. Option is second option. Next problem based on law of conservation of energy. That question is this one. A stone projected vertically upwards from the ground reaches a maximum height h. When it is at a height 3h by 4, the ratio of its kinetic energy and potential energies is. Ratio of kinetic and potential energies we are going to find when the object is at a height 3h by 4 in case of a vertically upward projected object. Means here we have to apply law of conservation of energy for vertically projected body. The ratios of kinetic energy and potential energies are given as first option 3:4, second 1:3, third 4:3, fourth 3:1. Solution. Here in case of a vertically projected body, what is maximum height is given? H. H is maximum height means at the maximum height position what is the velocity of the object? 0. Highest point velocity is 0. Maximum height, the velocity of the object is 0. Velocity 0 means what is its kinetic energy? 0. Means for this object at the highest point total energy is mgh only, potential energy form. Highest point mgh only. That means at every point in its journey total energy is equating to mgh itself. That means at the highest point total energy is mgh, means at every point in its path of journey total energy is mgh. At 3h by 4 height from the ground, potential energy formula is a what? mgh. What is h here? 3h by 4. That means potential energy is mg into 3h by 4. 3 mgh by 4. That is potential energy. Now kinetic energy I need. Why? Because ratio of kinetic and potential energy is required. So total energy is mgh. Potential energy is 3 by 4 mgh. Then kinetic energy is total energy minus potential energy. Kinetic energy is total energy minus potential energy. That is mgh minus 3 by 4 mgh. Kinetic energy is 1 by 4 mgh. What here the question is? Ratio of the kinetic and potential energies. Ke by Pe is equal to 1/4 mgh by 3/4 mgh. Potential energy, kinetic energy. From here, this is kinetic energy, this one is potential energy. These two values substitute here. mgh, mgh cancel. 4, 4 cancel. What is kinetic energy potential energy ratio? 1:3. Now, there is a shortcut method to find the ratio of kinetic energy and potential energy. That is another method. Here, ratio of kinetic energy and potential energy is equal to maximum height minus x. What is x here? Height of the object from the ground by x. Shortcut formula: kinetic energy by potential energy equal to h minus x by x. Suppose in the problem they are asking potential energy by kinetic energy, then x by h minus x. So kinetic energy by potential energy is h minus x by x. What is x there? X is the distance of the point from the ground. That is 3h by 4 in this problem. So kinetic energy by potential energy is maximum height minus x, height of the given point from the ground, 3h by 4 by x, 3h by 4. Here 4, it becomes h by 4 by 3h by 4. 4, 4, h cancel, then 1:3. Kinetic energy by potential energy is 1/3. This is one more problem. Next. The next problem is, a body is projected vertically up at certain height h above the ground. Its potential and kinetic energies are in the ratio 1:4. In this problem, potential and kinetic energy ratio is given as 1:4. Then, at what height above the ground, potential and kinetic energy ratio will become 4:1. That is the question. I think this question is exactly reverse of the previous question. There, the position of the object is mentioned and find the ratio of kinetic energy by potential energy asked there. Here, ratio of potential energy and kinetic energy mentioned. Find again the ratio of potential and kinetic energy at other position. At what height the ratio of potential and kinetic energy will be equal to 4:1. That is the question. Here the options are h by 4, 5h, h by 5, 4h. Solution. Here, to go to solution, first of all, at height h, the ratio of potential and kinetic energies. Shortcut formula I am using. That is, let capital H be the maximum height, then potential energy by kinetic energy is height of the point from the ground by maximum height minus height of the point from the ground. Small h by capital H minus small h, which is 1/4. Here mentioned, that is 1/4. Now, at certain height, we don't know that height. That height only we are going to find. What height? The ratio of the potential and kinetic energies are mentioned as 4/1. Means height of the point by x by maximum height minus height of the point is equal to this time 4:1, second equation. By using these two equations, from 1, capital H minus small h equal to 4h. From there, capital H equal to 5h. We obtain the maximum height in terms of the point height. From second equation, 4h minus 4x equal to x. From here, 4h equal to 5x. In this, in place of this capital H, I'll use 5h. 4 into 5h equal to 5x. 5, 5 cancelled. Then, x equal to 4h. The option is x equal to 4h. At x equal to 4h, the ratio of kinetic energy and potential energy will be 4:1. Option is this one, 4h.